Welcome to Spring LIB.
In this problem, we have a ring here pinched between two rollers. Um, the ring has an inner diameter or inner radius of 55 millimeters and an outer radius of 60 millimeters. And these two rollers have radii of 24 millimeters each. Now, we're told the angular, I guess I should, this is A, this is B, and this is C. So we're told the angular velocity of this roller is 300 RPM. And so we asked the various questions about, let's see here, what do we ask? The angular velocity of ring C and wheel B, and then the accelerations of a couple different points of these 2 points here on the rollers. All right, so the angular velocity, we know that if these things aren't slipping, there's no slip here, the velocity of this point from the roller and from the ring have to be the same. And from the roller, it's omega A times RA. And from the ring, it's omega C times RC2, or the outer radius of the ring. So that tells us that the angular velocity of this ring is 120 radians or RPM. Because this, we know what this ratio is, so we can just keep everything in RPM. Now, we know that if there's no slipping at this point, the velocity of the ring and the pulley and the roller here have to be the same. So from the ring, that is omega C times RC, RC1. And then from the roller here, it's omega B times RB. So omega B is this ratio here. And so we can plug in, let's see here. We know, this should be omega A. Let's see. Again, we can substitute in this thing here to there, and we know RA and RB are the same. So it just becomes the ratio of the inner diameter to the outer diameter times the angular velocity of this, and that winds up being 275 RPM. So slower than this because, again, there's a thickness to this ring. So if you're trying to drive these both at the same velocity, then you'd have slipping with one of them or both of them. Now they ask us for the acceleration on the rollers here at this point and at this point. So again, that's just centrifugal acceleration. So we have, in this case, we have RA times omega A squared. We can plug all of those things in. And again, we got to convert now our omega to radians per second. So this is 300 RPMs in radians per second. Doing the calculation, we get that that's 23.7 meters per second squared, and in this case, it's going to be pointing towards the rotation axis, which is in the positive y direction. Now, in this point on the roller, we have RB times omega B squared. Omega B in radians per second is 28.8. RA is the same as RB, so we can just plug it in. And we know everything, do the calculation, and we get 19.9 meters per second squared, again pointing towards the axis of rotation, which is in the negative y direction.